Okay, and we should be live. I think the audio is all good. Let me just check. Yeah, all good. Nice. Right, let's continue where we left off. So we were on. So we were on constant expression on if statements. Um, so normally, if a condition, if a conditional of an if statement. So at the moment, what we're doing, in case you don't know, is we're on control flow. Uh, uh, the control flow chapter. In the last stream, we started off by doing if statements and common if statement problems. Now we're doing constant expression if statements. Cool. So, constant expression if statements. Normally, uh, normally the conditional of an if statement is evaluated at runtime. However, consider the case where the conditional is a constant expression, such as in the following example. And remember that a conditional expression uh, is typically evaluated at compile time. So we got a standard input output stream library. We got a constant expression of double gravity. We're initializing it with 9.8 because we must do with a conditional expression. Constant expression always true. Standard character output, and then gravity is normal. We are not on Earth. Will never be executed. So because gravity is a constant expression and initialized with a value of 9.8, uh, uh, the conditional is always true. As a result, the else statement will never be executed. Evaluating a constant expression conditional at runtime is wasteful since the results will never vary. It is wasteful to compile code into executable code that can never be executed. Constant expression if statements. C++ introduces a constant expression if statement which requires the conditional to be a constant expression. Okay. The conditional of a constant expression if statement will be evaluated at compile time, like with most conditional, like with most constant expressions. If a constant expression condition evaluated to true, the entire if else will be replaced by the true statement. If the constant expression conditional evaluates to false, the entire if else will be replaced by the false statement if it exists or nothing. So we've set this to be a constant expression. Now using constant expression if. When the above code is compiled, the compiler will evaluate the compile time, see that it is always true, and only keep a single statement. Gravity is normal. In other words, it will compile like this. Favor constant expression over if statements. Favor constant expression if statements over non-conditional non-const expression if statements when the conditional is a constant expression. Okay. So essentially, if we are using a conditional expression, i.e. something that will be evaluated at runtime, then it is best to make the if statement a const expression if statement as well, such as turning this if statement, and then I'll copy that into this if statement. So I'll write it out myself. Include input output stream. We got a return type of integer for our main, and then we got a constant expression of a double of gravity, and we're initializing it with 9.8. Then we're going to be doing if const expression gravity equals 9.8. Standard character output. Gravity is normal. Else we are not on Earth. And then, as always, we'll return 0. Cool. So the constant expression has to be the use of const expression has to be after if keyword. Okay. The best practice is to favor cool, nice. All right. Nice. Okay. Let's continue then. Modern compilers. For optimization purposes, modern compilers will generally treat non-constant expression if statements a compiler that encounters a non-constant expression if statement may issue a warning. Okay. So switch statement basics. Although it may be possible to chain many if statements together, They are, this is both difficult to read and inefficient. So we're doing a void return type, print digital name as the name. We got a parameter of x, and then we've got if x 1 through 3. Yeah. And then in our main, we're printing digital name 2, and we're producing the output. So switch statement basics. And then I'll just copy that because that's pretty basic, and I know. So variable x in, yeah, because it will go through each line. I.e., if this is not true, it will then do this, and then if that's not true, it will then do this, and if that's not true, it will then do this. But because we're setting it to 2 for now, it'll go through this and say it's not true. Then it will go through this and then be like, oh, it is true, and it will stop there. But if we had 4, for example, or 0, it would go this one, this one, this one, and then it would reach this one, just wasting time. Because testing a variable or expression for equality against a set of different values is common, C++ provides an alternative conditional statement called switch that is specialized for a purpose. So to avoid this, C++ provides a statement called switch statement. The idea behind a switch statement is an expression is evaluated to produce a value. Then one of the following occurs. If the expression's value is equal to the value after any of the case labels, the statement after the matching case label is executed. Then if no matching value is found and a default label exists, the default label is executed. And then finally, the third possibility is if no matching value can be found and there is no default, the switch is skipped. Such as in this code. So because we're doing switch for the first time, I want to write this out myself. So we'll again, as always, include input output stream. We'll do an integer of main for our return type. We'll do switch, and then we'll do x. No, sorry, I'll actually do the void function first. Void print then inside here we'll do switch, and then we'll put the x in, and then we'll do case 1, standard character output 1, and then we're returning. Then case 2 with a standard character output of 2, and again we return. Then we do case 3 with a standard character output of 3 and return. And then we will do a default, i.e. if it's not 1, if it's not 2, and if it's not 3, we will then return standard character output of unknown, and then return again. I think that will go away. Then in our main function we will call print digital name, and we'll do 2, and then standard character output, and we'll do a line break. And then as always we'll return 0. What is wrong here? Okay, that's what I missed. So we should get 2 as a result when we run the program, and we do. Cool. Okay, nice. So now starting a switch. We start a switch with the switch keyword here, followed by brackets. So we can use to evaluate an integral type. So a switch statement can be used to, the switch statement conditional, aka in the brackets, must evaluate to one of the following: an integral type, an enumerated type, or be convertible to 1. and then expressions that evaluate floating points. Cannot evaluate floating point types, strings, and most other. Okay. Following the conditional expression, we declare a block. Inside the block, we case labels. Okay. The first kind of label is a case label. Which is declared using the case keyword followed by a const expression. This const expression must match either the type of the condition or must be convertible to that type. If the value so this is the case. So case 2 is it? So case, the label is the integer. If the value of the conditional expression equals the expression after the case label, execution begins at the first statement after the case label. So what that essentially means is, because we're running 2 here, the execution will start here after the case label, i.e. in our example of 2 in the argument, the execution will begin at case 2. Yeah. There is no limit. Okay. So that is not possible. Okay, good to know. So the second type of label is a default label. Yeah. to place Okay. Sometimes in other languages, such as Swift, you must put a default label because switch statements need to be exhaustive in Swift, not in C++. So that's just an example of how two languages can use the same thing but be different. Same, but different. Okay. If the value doesn't matter and no zero, then okay. Okay, yeah, that makes sense. Yeah, that makes sense. Taking a break. So then we have a break statement. So by using a break statement, this tells the compiler that we are done with executing statements within the switch tire, and that the execution should continue with the statement after the end of the switch block, thus allowing for the switch statement to be exited without exiting the entire function, such as this. And then I'm just going to do that myself as well. So we're going to do include input output stream, and we're going to do a void print digital name with the parameter of integer x, and then we're going to do switch x, and we're going to do case 1 standard character output 1, break case 2 standard character output 2, break again case 3, standard character output 3, and then a break. And then we exit the switch here, and then standard character output. And then we'll do and then because we used the break statement, the function will continue to here rather than ending like it did with return. And then we will do a return type of integer main to make this whole thing run. Integer name, we'll do 3. And then we'll do return. Then we'll do return of 0, and then we'll do a standard character output of a new line. Three, and then just did a space there. Cool. That makes sense. Right, nice. So, the best practice is that each set of statements underneath a label should end in either a break or return statement. Labels are conventionally not intended. Yeah, that looks horrible to read. So what is the difference? Sorry, what is the difference between this? Ah, okay. You're not indenting the labels. Okay. So you're doing this. Okay. So like that. So they're in line with the body. Switch versus else if. Switch statements are best used when there is a single expression with a non-Boolean integral type or a enumerator type. We want to evaluate for equality against a small number of values. If the number of cases gets too large, the switch can be hard to read. Okay. Compared to the equivalent if-else statement, a switch statement is more readable, makes it clearer that the same expression being tested for equality in each case, and has an advantage of only evaluating the expression once, making it more efficient. True. However, if-else statements are significantly more flexible. Some cases where ifs are typically better. You're testing an expression for comparisons rather than equality. You're testing multiple conditions for equality, determining whether the value is within a range. The expression has a type of switch that doesn't support, i.e. a double, which doesn't support switch. The expression evaluates to a Boolean. Okay. Switch, fall through, and scoping. This lesson continues our exploration of switch statements. So, fall through. When a switch statement expression matches a case label, execution begins. Yes, execution will then continue subsequently until one of the following happens. The end of the switch statement is reached. Another control statement, typically a break or return, causes it to be exited. Something else interrupts the normal flow. The OS shut down, the universe explodes, etc., etc. You know, standard stuff. Note the presence of another case label is not one of these terminating conditions. Thus, without a break or return, execution will overflow into subsequent. cases. So for example, so here we don't have a switch to execution begins here. So essentially what this means is if no break or return statement is used in our case labels, this means that the switch statement will continue to execute each subsequent line of code, including going to the next case label. So for example, if we did int main and then we did switch, no, I don't like that, switch to, and then we did case 1, and then we did case 2, and then we did case 3, and then we did case 4, and then we did default, and then in each one we did standard character output 1, and then 1, 2, 3, 4, and then 5. This would then print 2, 3, 4, 5. Yeah. Okay. The for through attribute. So like we did with maybe unused, C++ 17 has something for a for through attribute. So the intentional and intentional, such as, so we're just going to modify the code there and get rid of this, and then underneath here we'll do fall through, and then we'll break here. And we'll do a break here. And then this should stop at 2 then. 2, 3. No, sorry, because it will fall through, so it goes to 3. That makes sense. So this will print 2, 3. So the best practice is to use fall through attribute along with a null statement, aka no return or break, to indicate the fall through is intentional. Cool. Sequence case labels. You can use OR, the logic OR operator, to combine multiple tests in a single statement. So you got C or this suffers from the same challenges we presented in C. Remember, the execution begins. Labels do not define a new scope. With if statements, you have a single statement. Variable declaration and initialization inside case statements. You can declare or define but not initialize variables before and after case. Okay. Although y is defined in case 1, it was used in case 2 as well. All statements and so on. Okay. So the best practice is if you are defining do so in a block inside the case, i.e. here. Okay, write a function called calculate that takes two integers and a char representing one of the following mathematic operators: add, minus, times, divide, or modulus. Remainder. Use a switch statement to perform the appropriate mathematical operation for the integers and return a result. If invalid, the operator is passed into the function. The function should print an error message. For division operations, do an integer division. Don't worry about dividing by 0. Hint: operator is a keyword. Variables can't be named as operator. So let's give this a go then. Why not? So not yet. So we're gonna do our main function. Simple. So we're gonna do a so int calculate, and so we need a integer, we need a char of operator. Oh no, sorry. Or a char of symbol maybe. And then we need an int of y to times it by. So we're going to go here. We're going to do a switch statement. And then we're going to want to switch symbol. And then we're going to want to do within the switch statement, we're going to want to do a case. We're going to want to do case do we do case that? No, we have to do case 1. And then we'll do char add. And then we'll do we'll do this. Oh no, because you can't initialize it, can you? So we'll do char add. Then we'll do add equals this. So maybe it should be Boolean instead. Char C. And then we're switching C. And then we're doing case like that. Oh no, sorry, we want single perhaps. So char add, okay, and then we return x plus y, right? That's case add. Then we do the same basically for minus. So we'll do char minus, and we can't initialize. That's what it's missing. And then we'll return x minus y. Remember, we cannot initialize in a case label. We can only initialize outside outside of the case labels. Okay, I think we're getting somewhere. So if we go back to our question, and then we do, so that's add, that's plus, case times. Then we'll do char times, and we will return I'm wondering if we actually need char times, because where are we actually using it? Divide, because we're not actually we're creating it, but we're not initializing it, and then we're not actually using it anywhere. I'm wondering if we even need it, because we're changing the symbol here. So x divided by y. I'm wondering if we actually even need that, to be honest. And then finally we'll do modulus Where's my percentage? There it is. And then we're doing char more remainder, and then we'll return x remainder y. And then finally we'll do our default of return false, right? Because it's a Boolean. So we've done that. We've done our switch. Now we will do so we calculate it, but now we actually need to make sure that the user can enter something. So what we'll do is we will do in here int x char symbol. And then I don't think this is right though. I think there's probably a better way to do it. Char char symbol. So then we would do standard character output. Enter an integer. And then we're allowing the user to standard character input, and then it'd be x. Then standard character output, enter the enter an operator, and then we're allowing the user to enter the operator. Then we're saying to the user, enter another integer, and standard character input y. Then we calculate standard character output that should be the other way around. Exertion, not insertion. Calculate x symbol y, and then I don't think that's right though. That doesn't seem right. Again, I don't think that this is necessarily so we're switching the symbol, and that's our symbol here. But we're not actually calling this anywhere. So let's just see if it works. Enter an integer 2, enter an operator, we'll do times, enter another integer 2, so we should get 4. The result is 1. So something is happening there. Oh, so that's all it was. So we just needed to change integer to calculate. But again, I think we can make this code better. I don't think we need all this. So let's run that. Enter integer 2, enter an operator plus, enter an integer 2. Maybe I'll do 2 plus 3 just to make sure it works. So 2 plus 3 is 5. Okay, so that works. Perhaps it would be easier if we if in calculate we added this instead. Or we did or we move this into calculate. Above the switch. Let's try that. So above the switch, we'll do that. No, but then that'll run each time. So no, that won't be right. What we could do is then we'll do ask user, where we would this wouldn't work, would it? No, didn't think it would. We could do that. Then we could ask the user for an input. User input. And then we would do again int x char symbol int y. Then we would do standard character output. Enter an integer. Then we would allow the user to enter said integer. No, forget that. Let's see. So we know it works, but let's see if it can be more efficient. Oh, so that's what he did anyway. And I probably should get into the habit of only defining and initializing as empty when I'm actually calling it. Yeah, that is a much neater line of code. Um, okay, so he just put result into calculate, which is fine. And perhaps I should have realized that, but I didn't at the time. Okay. Yeah, I'm fine with that. Again, I was right. I don't actually need these because we're defining them. We're not initializing them or we're not assigning them with anything. Um, so instead of return false, yeah, that makes sense because we're not a Boolean anymore. We can get rid of that and we can do standard character output of un and unhandled case, and then we'll return 0. We're returning 0 rather than false because it's an integer, although 0 is false, so false would work here. Anyway, I'm going to take a break and I'll be back in a minute, and then we can do go-to statements. let's continue now with go statements. Okay, still good on the sound? Let me just check something. Hello? Yeah, we're good. Get rid of that. Okay, go statements. Sorry, go to statements, not go statements. So I've never actually come across go to statements. Another type of control flow statement is unconditional jump is a go to statement Sorry, there was just a moth in this weather. Or also known as an unconditional jump. An unconditional jump causes the execution to jump from another spot to jump to another spot of code. An unconditional jump causes the execution to jump to another spot in the code. The term unconditional means the jump always happens. Okay. The term unconditional means that the jump will always happen, unlike an if or switch statement. Where the jump only happens conditionally based off the result of the expression. The unconditional jump in C++ is implemented via the spot of code it jumps to is identified through the use of a statement label. Okay, this seems interesting. So we got input output stream. We got a character header of. We got the library of C maths for the square root function. So we're creating a double. Then we're doing a statement label of try again. Then we're doing enter a non-negative number. And then we're doing standard character input. If x is less than 0, go to try again. Else, i.e. breaking out of that, we return the square root. Okay, let's give that a go. So include as standard input output stream, then include the math for the square root function. Then we'll do a return type of integer for our main function. Then we'll create a uninitialized double. Then we will use a statement label of try again. Okay, so it's not a keyword. This is a and will be what we will jump to / go to. As you can see at the moment it's undefined, but that's okay. Then we'll do standard character output telling the user to enter a non-negative number. Then we will allow the user to enter said number, which will be, I realize I haven't provided an identifier for my double, so which will be x. And then if x is less than 0.0, we will go to try again. Standard character output, the square root of is standard square root of x. Return 0. Now, how come I'm not getting that? Try again. That's why. Okay, so you need a colon, not a semicolon. So to make this defined, because it's a label, we need a, as it is a label, just like you would do in a switch statement with something like case 1 or case X. That makes sense. So let's try it. Enter a non-negative number. We'll do 1.1. We'll do 9, so it should produce 3. Square root of 9 is 3. Now let's enter a negative number. We'll do negative 9, and then it just keeps asking. Okay. That is very useful. Surprised I assume the reason why I've never heard of GoTo is because a lot of people in a lot of languages would use a while statement, I think. But it seems like a lot less code, unless there's something wrong with the GoTo statement. Okay, so in this program, however, yeah, statement labels have function scope, local scope, block scope, file scope. Yeah. In this chapter's label, the GoTo statement is. So statement labels utilized in the function scope means the label is visible throughout the function even before the point of declaration. The GoTo statement and the corresponding statement label must appear in. Okay, I definitely need to make a note of this. That should be that. And so should that. Okay. Okay. While the example above shows GoTo statements can also jump. So GoTo statements can also jump forward. This is an example of a GoTo statement jumping backwards. So let's definitely do a copy of this. So we're going to do include output stream, and then we're going to have a void print cats, and then we're going to have a boolean of skip. And then within the body, if we are skipping, then we go to end. This jumps forward statement to statement label end. Label end. and end is visible due to it having a function scope. So this is all about in the function scope. So then we come out of the if statement, the standard character output, cats, and then a line break, and then here we go end. And then in our main function within a return type of integer, we do print cat true, and then we'll do print per int cat, and we'll call that false. So this jumps over the print statement and doesn't print anything. This prints cats. And then as always we'll return 0. So Boolean if skip is true, if skip is true, we go here. Okay, so if skip is true, then we jump forward to end. Whereas if skip is false, we run the rest of the function. And let's just run it. We got a warning. Why do we get a warning? Cats, that's why, because that should be double quotation. And then we'll run it again, and we get cats. Whereas if we get rid of this, we won't actually get anything. Yeah, see? Okay. So go-to statements can be used to jump forward or jump backward. To jump backward, or it can be used in a function scope to jump forward. If within a scope, function scope. Beyond the jump forward, there are a couple of. First, note these statement labels must be associated with a statement. Okay. I.e., you must. Oh, I missed that actually. I missed that the first time around. Okay. Because the end of the function had no statement. So the statement is this. Okay, so that's the syntax basically. So the point you want to jump forward to must be followed by a statement label and then a semicolon. That wasn't the case with this, was it? No, it wasn't. Second, we were able to jump to the statement labeled by end, even though we hadn't declared end yet in the statement. Labels having function scope. No full declaration of statement labels is necessary. Third, it is worth explicitly mentioning that the above program is poor form. It would have been better to use an if statement to skip the print rather than just go over. There are two primary limitations to jumping. You can only jump forward in a single bounds of a function. You cannot jump out of one function and into another. And if you jump forward, you can't jump forward over the initialization of any variable that is still in scope. Okay. So go to skip, and then X is still initiated. Okay. Note that you can jump backwards over variable initialization and the variable will be reinitialized. Okay. Okay, I'm just going to put my laptop on charge. Right. There are two. So avoid using go-to statements. So I wonder, maybe because you're able to jump, right? Maybe you just use while statements instead. Avoid using go-to. Use of go-to has been shown in C++. The primary problem with goto is that it allows the programmer to jump around arbitrarily. This creates what is known as, not so affectionately known as, spaghetti code. Spaghetti code is the path of execution that resembles a bowl of spaghetti, making it extremely difficult to follow the logic of such code. Okay. Yeah, as I mentioned earlier, a lot of people use while statements, and I've never seen that. If one notable exception. Okay, so avoid using goto then. So, and maybe I'm not advanced, but let's still take a look. So we got a for loop where we're initializing it with I equals 1 with the condition of within 5, and then we're increasing I. And then within I, we're within the for loop, we have another for loop which is doing the same thing but for j. So standard character output I times j is I times j. So 1 times 1, 1 times 2, 1 times 3, all the way to 5. If the product is divisible by 9, jump to the end. So ending early, yeah. And then we're done. I could reshow. Ha! Okay. Introduction to loops and while statements. So there we go. We're now on to loops and while statements. Okay. Just going to take a break here and then we can continue with for and while statements. where were we? I think we were on for loops, weren't we? Okay. Let's continue then. Okay, for loops to loops and while statements. So, loops are control flow statements that allow a piece of code to execute repeatedly until a condition is met. Loops add significantly amount of flexibility into your programming tooling kit and allow you to do many things. Yeah, so this is where it really gets interesting. Let me just copy that. For example, let's say you wanted to print a number between 1 and 10 without loops. You might try something like that. Yes, very interesting. But what if you wanted to do 1 and 1,000? Well, you'd have to do a literal for 1 to 1,000. What if we wanted to ask the user to enter a number? Exactly. Okay, so while statements. So, as far as I'm aware, the main loops are while loops and for loops. So, while statements and for loops. So, we want to do while loops, and a while loop essentially runs until the condition is met. So, the while statement, aka a while loop, is the, so there are 3 loops. Is the simplest of the 3 loop types that C++ provides. And this is the syntax. Syntax. So we got while condition is true, run this statement. However, unlike in this statement, once the statement has finished executing, control returns to the top of the while statement and the process is repeated. This means that while statement will keep looping as long as the condition is true. Let's take a look at that for an example. So let's try it ourselves. Include input output stream. Then we have a return type of integer for our main function. Then we have an integer of count, and we're initializing it as 1. Then we're having a while loop, while count is less than or equal to 10. We will do a standard character output of count with a line break, with a space. Then Then we will use count to add, we will add to count. Then once we've done that, so whilst count is less than or equal to 10, add 1. And then we will do all done. No, character output, not count. And then return 0. And then we'll clear the terminal and we'll run this code. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all done. Nice. Yeah. So the above while loop will continue until the condition, aka count, is less than or equal to 10, until it is no longer true. Cool. Now, while statements that evaluate to false initially. Note that if the condition initially evaluates to false, the associated statement will not execute at all. So let's give try an example of include input output stream, an integer, a return type of integer for our main function. Then we do int count count, and we'll initialize it as 15. Then we'll do while count is less than or equal to 10, and then we'll do standard character output count, and then we'll add to count. And then we'll do standard character output all done. And as you can see, we just get all done because this is 15, and we want to run a while loop of when count is less than 15. Well, sorry, less than 10, and that will never be the case because count is 15. On the other hand, yeah, you can get into while loop hell, basically, where if the expression is always true, the loop will continue forever. Here's an example. So you got a integer count of 1, and while count is less than 10, we will produce count. So this will go on forever and ever and ever. And this line will never execute. And you will just literally have 1 forever and ever. Let's have a look just to show you and show myself. So, while statements and in oops. So let's do that. So we'll change this to 1, and then we won't add, and then we should just get 1, 1, 1, 1, 1, 1, 1 forever. There you go, look at that. And you can see it's continually printing 1. And so what I'm going to do is I'm going to press Control C to exit that. So you got to make sure, get out of here. There you go. You got to make sure that you write your while statements correctly. This will just print 1 forever. Forever and ever. Yeah, cool. Intentional infinite loops. You might want to actually do it intentionally, it seems. Intentional intentional infinite loops. We can declare a intentional infinite loop like this. An intentional infinite loop can be written like this. So you got while true and then code here will execute forever. Okay. The only way to say break statement. So the only way to break out of the infinite loop is through the use of a break statement, which is what we learn in our switch statements. An exit statement, a go to statement, an exception being thrown, or the user kills the program. So you got a while true standard character loop again. If C equals N, return 0. Let's just try that rather than having to press Command C. So you got include input output stream. Then you got int main, and then you got a while statement, while true, standard character output, loop, again, yes or no. Then we do char C, uninitialized. We allow the user to enter C, and then if C is equal to N, then we will return 0. And then outside here, we will return 0. And that needs to end with a semicolon. Yeah. And just to prove that, We'll do standard character output. Clear that. That is probably because it should be like that. Okay. So unintentional. Okay. Where was I? Here. Unintentional infinite loops. Unintentionally placing a semicolon after the condition of a while loop is a good way to hang your program. Here's the pro example showing what will happen if this simple mistake is made. So you were putting a semicolon here. Written so unintentional. Unintentionally playing. Here's a prime example. So let's just give that a go, shall we? So include input output stream, return type of integer for our main function, while integer of count initialized as 1, and while count is less than or equal to 10 with a semicolon, and then the body of the while, standard character output, count, count, and then we're going to increase count with a prefix. And then we're going to do standard character output, all done, with a line break, and then return 0. Yeah, let's have a look what happens. So as you can see here, we actually get a warning sign while loop has an empty body. So if you mistake, if you unintentionally, this will essentially mean your while statement has no body / block and ends right away, hence why it is in hanging. Yeah. Okay. And you can see here we get this error. The above code is essentially like writing this code. We get this error message. Yeah. And then as you can see here, we never actually get anything. We just, the code just hangs and doesn't run. So let me just clear that. Cool. So be careful, yeah. Yes, definitely be careful. Okay. Loop variables and naming. Okay. Yeah, that'll be fine because I'll be getting rid of that eventually. A loop variable is a variable that is used to control how many times a loop is executed. Yes. For example, while count 10, count is a loop variable. For example, yeah. Whilst most loop variables have a type integer, you will occasionally see other types, e.g. a character type. The use of IJK. Yeah. So, however, if you want to know. So, what is a counter? Integral loops variables should be signed. So, integral loop variables should always be signed, and unsigned integers can lead to unexpected issues. So you got an unassigned integer, count 10, no, unassigned, which means its range cannot go below 0. So count from 10. So while count is greater than 0, if count is equal to 0, that. Else count and then that. And we're subtracting count after every loop. Take a look at the example and spot any errors. It's not very obvious if you've never seen it before. Let me try and find it. So, while count is greater than or equal to 0, Surely this should be above this, no? Um, I don't think you need this in the else statement. You could just do standard character output count minus count, and then at the end, if it's all done, blast off. It has a... And of course we have unassigned. True, yeah. Because we're making it equal to. Okay. Doing something every n iterations. So I think it'd probably be best if I actually wrote that myself. So return type of integer for our main function. I'm going to do unsigned int count and assign it with 10. And then we'll count down from 10 to 0. So while count is greater than or equal to 0, we run this code. If count is exactly equal to 0, then we will say blast off, else count, and then subtract count, and semicolon, and then we'll do standard character output, and then a line break, and then we will return 0. Yeah, there we go. That's an example there. You see all that? That is exactly what would happen. Because when count is 0, it means that it can be less than or equal to, or greater than or equal to, which means 1 is greater than or equal to, and 0 is not greater than, but it is equal to. Let me just stop that there. So if we just did that, is that the correct way to do it? Yeah. But then the issue is that it won't actually get to 0 because we're only doing the range of count being greater than 0, and it can't go to it won't eventually go to 0. If we got rid of that, would that run? Yes. So we get rid of unassigned and it works. So in the above example, if we got rid of unsigned, then the program works as intended. Okay. Doing something every n iterations. Each time a loop executes, it's called an iteration. Often we want to do something every second or third iteration, such as print a new line. This can easily be done using the remainder operator on our counter. So let's write it out ourselves. Include input output stream, return type of integer for our main function, and then we'll do int count. We'll assign it to be equal to 1 to begin with, and then so while count is less than or equal to 50, print the number. So standard character output, and then we're doing 0. So, and then if the loop variable, aka count, is divisible by 10, print a new line. So if count is divisible, if count divisible by 10 has a remainder of 0, then we will produce a new line. And then outside of the loop, we will add count. And I can see now why he's used if statements here. Hang a minute. What have I done there? I actually needed that in an if statement. So if count is less than 10, do that. Yeah, and I can see now why he's used brackets there, because it can be a bit confusing as to whether count is part of the if statement. So we'll just get rid of that and we'll print that. And then we will return, and our count actually, and I'm making all the mistakes today. This needs to be within our while loop. because otherwise it will not run. So let's run that, and you can see you get a nice 10 by 5 grid. Okay. Nested loops. Okay, so how long is this? Okay, so not that long. Well, so nested loops, and then quiz time. So what we'll do is I'll take a quick break here, and then I will come back. And we'll finish off while loops. Okay. Let's continue. Right, so nested loops. Yeah. So we'll include that. Nested loops. It's also possible to nest loops inside other loops. Nested loops tend to be a bit confusing for new programmers, so let's start a slightly easy example. So again, I'll probably just copy and paste this, or no, try it myself. So I'll do include input output stream, then we'll do a void of print up 2, and we'll do an int of order. So we'll do loop between 1 and outer. Note the inner will be created and destroyed at the end of the block. So int inner. So while inner is less than or equal to outer, but outer hasn't been defined yet, that's why we're getting the error. Standard character output inner and then we're adding inner. Oh, sorry, that should be outer, not inner. Not order, sorry. And then now it's defined. Cool. So while inner is equal to 1, well, we initialize inner with 1. Remember, signed, not unassigned. Then after that, what we do is we loop through while inner is greater than or equal to outer, print inner, and then we will add to inner. So we'll print inner, then the first one will be 1, then we'll print 2, and so on and so on and so on and so on and so on. Now, since we haven't defined outer, it will keep going. And our inner is destroyed here because the scope finishes here. The scope is defined in finishes here. So inner is destroyed here. So outer loops between 1 and 5. Int main so int outer, we'll initialize it with 1, and then we'll do while outer is less than or equal to 5. For each iteration of the outer loop, the code of the body executes once. Yes, that makes sense. Then this function prints numbers between 1 and outer. 1 and outer. So print up to, and we're doing outer. Print a new line at the end of each row. Standard character output. And then a new line. And then we're adding outer after each line. And then we will return 0 as always. So let's give this a go, see what happens. So what outer is 1, and so while outer is less than 5, we're going to repeat this whole loop. Now, the first thing we do in this loop is we print up to, i.e. we run this code, and we print our outer function. So we will get 1. So we'll get 1. And then we'll print 1 there, and then we'll add outer. So we get a sort of a beginning of a half of a Christmas tree. So our first loop is to print 1. Then we create a new line. So once we've printed 1, we then print a new line and we add to outer. So outer goes from 1 to 2. Then we go back to the top of the loop and we start a new iteration. So then we go to print outer. So again, we go here and in this case, we now have 2. So now we're doing 1 and 2. In this example, we have a outer loop with a counter name outer that counts 1 to 5. For each iteration of the loop, the body of the loop calls print up to using the outer loop variable. Prints new line and increments outer. The print up to function also has a loop and prints all the numbers that have been passed in. Therefore, when outer is 1, the loop calls this. So this becomes 1. The argument becomes 1. The loop body then prints a new line and increments out. Now outer is 2. It's essentially the same as calling this to be 2, which prints 1, 2. Because here we're increasing inner and we're getting 1 and 2. The loop prints another new line and increases outer. And again, we're checking if inner is less than outer. And then it goes all the way to 5. Note that in this form, a nested loop in the body of the outer loop, we are calling the function that has a loop itself. In other words, iteration of the outer loop, the loop in the function executes. So we're just separating. So what he is essentially what he's saying is we could move this. We could move this into where this is. I definitely need to add that to my notes. There you go. All right. So here we have an outer loop I will get rid of this. I'll get rid of this. So we have an outer loop. While outer is less than 5 for each iteration. Yeah. So we're essentially making it inline now. Essentially making it inline now. So int inner is assigned 1, and then our nested while loop will be if inner is less than or equal to outer, then we will do standard character output inner, and then a space, and then we will increase inner. And then we'll just do the same. And then this should have the exact same output. And as you can see, it does there. And then our inner is destroyed. Okay. So what we've done is we basically moved this whole function into and replaced it here. Because we have a 1, we've done this. That makes, maybe because of my experience and my knowledge, but this seems, and my lack of, this seems a bit easier than separating into functions, although it is still the same as doing this with a void function. Although I think perhaps I should write more functions rather than adding lines of code, because then you're just adding and adding to your main and it becomes harder and harder to read. Okay, let me we can also just take, or we can also just remove the function and write the code in our main like this. However, perhaps this is not ideal, as it is just clustering the main function and making it harder to read. Okay, let's try the quiz time. So in the above program, why is the variable inner declared inside a while block instead of immediately following the declaration of an outer? This is because the variable inner is declared inside so that it is recreated and reinitialized each time the iteration. If the inner variable were declared before the while, it would never be reset to 1, or we'd have to do an assignment statement. Furthermore, because variable inner is the only is only used inside the nested while loop, it makes sense to declare it there. Remember, you declare your variables in the smallest scope possible. Write a program that prints out letters A through Z with the AS codes. Use the loop variable of char. And a hint of to print chars as integers, you have to use static cast. Okay, so what he wants is A to Z in their number in their ASCII form. So and expression. Okay, so I won't put it into other functions for now. I'll do int main and then that prints out the letters. So we want to convert it from numbers from characters to integers. So what I think I'll do is I will do char of letter, and I'll assign it as, I'll leave it unassigned. Then while letter So we'll do A for now. Char 97. So the ASCII for A is 97. And what is Z? And for Z is 122. So we'll initialize it with that. While letter and then static cast int no. Static cast int letter, while static cast int letter, and that turns it into an integer, is less than is less than or equal to 122, we will do a standard character output of letter. And then we will do, what did he want? He wanted, okay, he didn't necessarily want anything. And then we will add to letter. Oh, that's because I have not done my include input output stream. There we go. So now we will print outside of the loop, we will do those are all the AS numbers from letters A to Z. And a line break, and then return 0. Let's have a look if that is actually correct and right, and actually prints what we want. So we want to go from 9, let's go. Okay, so that hasn't actually done anything. So it's printed out the A to B. While letter, so this has gone there. Standard character output, and what we actually need to do is if we did that instead. Cool. So then does that mean we do that and that will still work? Yeah, that will still work. But then yeah, let me just is that the absolute best way to do it? So we're actually getting the correct numbers from A all the way to Z, but is that the most optimal way to produce the code? So we're doing a standard character output and we're converting it from a character to an integer. And then we're adding to the letter. Let's have a look. Car, my car. Yeah, A. Okay, so we should have done Z instead. That makes sense because we haven't actually set that to static let. Static cars. Okay. Yeah. So we did, or we do not need to use static cast int letter here because yeah, here because letter is still a char. Okay, how we look on the time? Okay. We'll probably do another 10 minutes. We'll see where we are when we get. So, yeah, we're still good. Yeah, so I'm happy with that. Invert the nested loop example so it prints the following. So now make it print like this. So we've got 5, 4, 3, 2, 1, 4, 3, 2, 1. So we are let's see where we are by one in about 10 minutes, and if not, we'll have to do that when we come back. So include input output stream. We'll do an integer of main. We'll set our outer, yes, our outer int. Actually, I want to get better at using I want to get better at you. We'll actually no, we'll do that first. So we'll do int outer equals, so it'll be 5 in this instance, while outer is greater than or equal to 1, while outer is greater than or equal to 1, so for each iteration the code of the body will loop, code of the body will execute once. Then we need an inner loop, and then that again will also be 5. So int inner is 5 initialized, and while inner is greater than or equal to outer, then we will print inner, and then we will subtract inner. Then we want to print a new line with a standard character output of new line, and then we will decrease outer. And that actually needs to be, so that needs to be here, and that should be here. Let's have a look just to see what happens. So before we run it, we'll do outer is here. If while outer is greater than or equal to 1, then we will do inner equal 5. While inner is greater than outer, we will print inner, and every iteration will deduct inner, so it will go from 5, 4, 3, 2, 1. And then after this is done, we will then deduct outer by 1, meaning that as soon as it gets to 1, it will be false. Let's have a look. Okay, so we got the other way around. So we wanted 5, 4, 3, 2, 1. So if we make outer equal to 1, and then if it's greater than 5, what will that do? That will do absolutely nothing. We add outer. No, so that just... Okay, so we need to deduct outer. So we are starting at 5. So while in this way? No. Inner equal to 1. Okay, so we're getting there. What if we add to outer? So we're getting to our result, but we're not actually printing anything above. No, so that just leaves us in hang. We just need to invert it. So while is that it? What about if we move that to there? No. What if we set that to 5? Hey, there we go. No. Other way around. Outer is 1 and 5. And then you're adding to outer each time you loop. There we go. Cool. No. That didn't work. I thought it did. Okay, so I think we'll leave that for today, and we'll have to come back to it tomorrow. Yeah. So that's where we'll leave off of. We're getting the lines, but we're not printing the numbers. Probably because I'm doing something wrong here. But we'll have a look tomorrow. That's what we'll do. So what we'll do is left off at lesson 8.8 and need to finish the quiz. Okay. Let's take a look at our notes. Day 15. So we did const expressions, if statements. We did switch statements. Switch statements. We did case labels. We did default labels. What was the other one? Break and return statements. We did switch versus if else. We did fall through, fall through, fall through attribute. We did variable declaration. And initialization inside case statements. We did go to statements. We did statement labels have function scope. We did avoiding go to. Then we did while loops, and I think that was it, wasn't it? We did while loops, infinite, unintentional, loops and naming. Again, still while loops. We did nested while loops. And then, yeah, so we finished off there, and we tomorrow will be doing, we'll be starting off by finishing the quizzes. Okay, print that, I'll clear our terminal for now. And yeah, so that'll be it for today. Hopefully you enjoyed the control flow a bit more. It's a bit better than what we did yesterday about scopes, duration, and linkage, but those are still very important things. So if you saw something I did wrong, let me know as always. And if you'd like me to do coding a different style, let me know. But yeah, as always, like, subscribe, and comment, and all that good stuff. All right, see you in the next one. Bye.